The planetary manhunt continues. Although researchers have now managed to detect more than 7,400 exoplanets, Earth's cosmic twin is still slumbering in hiding. But who knows, maybe the next habitable world is right on our doorstep after all. For example, Proxima b, only 4.2 light-years away, is not just any rocky planet. It is a celestial body that orbits within the habitable zone, and may even have already given rise to life. But what has the investigation of the exoplanet closest to Earth revealed? Does Proxima b really embody Earth 2.0? And is it true that the James Webb Telescope has even captured a brightly lit alien metropolis there? Be sure to stay tuned until the end and join us in getting to the bottom of these exciting questions. No other star comes as close to our home system as Proxima Centauri. In fact, the red dwarf is only 4.24 light-years away from the Sun. But while this distance may sound like a cosmic hop, skip, and a jump at first, it becomes all the more enormous when we consider what it actually means. According to this, the length of a light year is the distance that light travels in a vacuum in 1 year, which is an impressive 9.46 trillion kilometers. In other words, this means that the distance between the Sun and Proxima Centauri is more than 40 trillion kilometers, and that despite its relative proximity to us, the star is therefore an unreachable distance away. Well, at least as things stand at present. With current propulsion technologies, it would take several millennia for a space probe to bridge this enormous distance. It is true that NASA and others are currently looking for ways and means to make the dream of interstellar travel a reality. But at present, no one can predict whether and when the relevant concepts will be put into practice. And so for the time being, we have to resign ourselves to the fact that we cannot take a closer look at Proxima Centauri, and that is certainly regrettable. After all, the star does not travel alone through space. On the contrary, according to our current knowledge, the celestial body serves as a central star for at least 3 planets. And while the most recently discovered Proxima d has only a quarter of the Earth's mass and is too far inside the habitable zone, Proxima c, which orbits further out, could be a mini Neptune. But then, of course, there's also Proxima b, a planet that has been considered a potential twin of Earth since its discovery in 2016. Is Proxima b really Earth 2.0? And how do you even detect a planet tens of trillions of kilometers away? Do experts simply point their high-tech telescopes in the direction of a potential host star and capture the alien world directly on film? Well, not quite. In fact, exoplanets are mainly added to star maps using indirect detection methods. More precisely, the so-called transit method has proven to be the most successful method. It has been used to identify around 70% of all exoplanets known to date. In this method, a planetary companion reveals itself through the changes in brightness it causes as it passes in front of its host star. In the case of Proxima b, however, it was not the transit method, but the radial velocity method that added a remarkable entry to the list of known exoplanets. When a planet orbits a star, it always influences its gravity. In practice, this constellation manifests itself in the form of a slight regular fluctuation in the light spectrum. And although such a star dance can sometimes only be a few cm wide, it is enough to reveal the existence of a previously unknown planet. And things get particularly exciting when the planet also moves within the habitable zone of its home system. But what exactly does that mean? Well, the potentially habitable zone encompasses a distance range in which a planet must orbit its central star in order for water to exist in a permanently liquid form on its surface. Ultimately, however, the mere presence of the elixir of life is far from enough. Other factors such as the composition of the atmosphere or the radiation from the parent star can still thwart life despite all the favorable conditions. But what is the situation in the case of Proxima b? Well, with a mass of 1.17 Earth masses, it's basically considered an Earth-like exoplanet. But let's not get the wrong idea. The term Earth-like simply refers to rocky planets with a solid surface without making any statements about their habitability. And while our blue home planet is known to take 365 days to complete a full orbit around the Sun, Proxima b only needs a little over 11 days to do the same. This is due to the short distance between the exoplanet and its central star. While the average distance between the Sun and Earth is 150 million kilometers, Proxima Centauri and Proxima b are only 7 million kilometers apart. Given this situation, it stands to reason that the planet's surface must resemble a scorching hot furnace. And that is true, but only partially. As briefly mentioned at the beginning, Proxima Centauri is a red dwarf. We are therefore dealing with a star whose mass is only about 12% of the Sun's mass. However, the data collected so far indicate that, unlike Earth, Proxima b does not rotate around its own axis during its journey, but instead has a bound rotation. This simply means that it always faces the same side toward its host star, and is therefore divided into two opposite extreme zones. More precisely, the split face of Proxima b consists of a freezing cold night side and a significantly hotter day side. But doesn't such a division make the development of life impossible from the outset? Well, not necessarily, because between these two extreme zones, there could be a narrow strip that actually offers conditions conducive to life. But that's not all. The sharp contrast could actually favor the conditions for life on Proxima b. Simulations by scientists have shown that the twilight zone could draw its supply of liquid water from glacier on the night side which melt near the habitable strip and feed the lakes and rivers. Has Proxima b already given rise to life? Well, that's a question that unfortunately cannot be answered with certainty at this time. The answer to this question, or more precisely to the question of whether there is liquid on Proxima b, depends on a number of parameters that have not yet been conclusively verified. However, assuming the right orbit and a favorable atmospheric composition, a simulation conducted in 2017 concluded that cool water could indeed be sloshing around there. Nevertheless, the actual habitability of the planet remains hotly debated, primarily due to the turbulent activity of Proxima Centauri. According to this, scientists at the University of Colorado observed something some time ago that left the entire research community speechless. We know that our Sun repeatedly draws attention to itself with bursts of radiation known as flares. However, what the experts saw flaring up on Proxima Centauri was a whopping 100 times stronger than any solar flare ever recorded. The red dwarf increased its ultraviolet radiation 14,000-fold within seconds. And in fact, the eruptions there are not only far more extreme, but also much more frequent than in our home system. In view of this, it can be assumed that the intense stellar radiation will completely destroy Proxima b's atmosphere over time, killing off any chance of life. Or will it? Well, not necessarily. There is a scenario in which the planet does not lose its atmosphere to space. To do this, it needs a liquid core that forms a stable magnetic field, and thus blocks the dangerous radiation from Proxima Centauri. This could keep the water molecules and oxygen on the celestial body. However, it's also conceivable that Proxima b is still drawing on its original water supply. One theory is based on the assumption that the exoplanet initially formed much further out and was only later captured by Proxima Centauri's gravity. Furthermore, it's possible that Proxima b once had 10 times more water than Earth. And even if the intense radiation had already robbed it of 90% of that, there would still be enough left today for a huge ocean covering large parts of the surface. However, due to the natural division of the planet, it's in the nature of things that water temperatures would only be moderate in the narrow twilight zone. Has the James Webb Telescope photographed a city on Proxima b? But why are we still talking about theoretical water reserves and destructive stellar radiation when the James Webb Telescope has already captured an artificial sea of lights on Proxima b? Added to this is the fact that members of the Breakthrough Listen project received a potential radio signal from a Proxima Centauri system some time ago. Could it be any clearer? Well, of course not, because at the end of the day, neither report has anything to do with reality. When it comes to the supposed city lights, this is a generous interpretation of a completely different observation. And that's putting it very kindly. According to this, we detected a fascinating methane light show in the vicinity of the brown dwarf W1935, which however has nothing to do with any alien metropolis on Proxima b. In the case of the radio signal mentioned, however, it is indeed correct that it had an artificial origin, albeit with a small but crucial caveat that it ultimately originated from Earth. The signal dubbed BLC-1 was simply the result of the distortion of the terrestrial radio signals. And so it is that the mysterious WOW signal of 1977 remains the most promising candidate when it comes to the question of extraterrestrial messages. And the subscribe button is still the best way to make sure you never miss a new video from us. Hit the thumbs up and subscribe now to stay up to date. We'll see you soon.